Okay, so today we're going to talk about solving systems of linear inequalities, not equations this time. All right, and that's our learning target. Before we get going, how many almonds are in the big container here? All right, how do we solve systems of linear inequalities? Well, before we do that, if you remember when we graphed linear inequalities before, we drew a boundary line, we did a test point, and then we shaded one way or the other. So in order to draw your boundary line, you need to remember the different types of boundary lines that you can have. So they usually come in 4 different kinds of lines, either in slope-intercept form, y equals mx plus b. If that's the case, you want to plot the y-intercept and then use the slope to get your other point or points. And then if it's in standard form, ax plus by equals c, we usually use the cover-up method, and that finds your x and y intercepts. In other words, where it crosses the x-axis and the y-axis. And then you plot those 2 points and draw your line. And then the other kind of lines are horizontal and vertical lines. Vertical lines are x equals a, like x equals 5. Vertical line that passes through the x-axis at 5. And then horizontal lines like y equals b crosses the y-axis at b. Okay, so those are 4 kinds of boundary lines that you're going to see here in your assignment on this. So in order to find solutions of inequalities, linear inequalities, we graphed them. And if you recall, on the left there I wrote greater than, less than. If they're those, the boundary line is not included, so we used a dash line. If they're greater than or equal to or less than or equal to, then we use a solid line. Remember, the boundary line is where it's equal to, so that's why it's solid if for those 2. Okay, so now let's go through this. We're just gonna, a system, remember, is just more than one here. So that's why we're gonna plot both of these on here and see where our solution region lies. So I'm gonna start with that first inequality, y is less than or equal to 3x minus 7. These are both, notice, in slope-intercept form. So we are going to plot our y-intercept first. So let's say this one I'm gonna do, so you can see what's going on here. We'll do this one in purple color, so you know where that's coming from. Okay, so the y-intercept is -7, so I'm gonna make a dot on the y-axis at -7. This is now your starting spot. So from here, my slope is 3. Remember, in order to do this, you need to make this a fraction, so I'm going to put it over 1. Slope is rise over run, so that would be a rise of 3 and a run of 1. So I'm going to go up 3 units and 1 over. I don't want to have that there, so I'm going to erase that, but I'm going to put a dot right there. Okay, and now you can do this multiple times if you wish. If you want to go up 3 and over 1 again, that's up to you. You need at least 2 to make a straight line, though. So now I'm going to draw my line all the way through the graph. You can hold it so it straightens out. And then if you need to make adjustments, the best way is to use the scissors and just tap on the line. The ends will highlight, and you can just kind of adjust as necessary. Okay, so there we go. I've got my line, and it is a solid line because this is less than or equal to. So I'm going to leave it like that. Put my arrowheads on there. And now I've got to figure out which way to shade. So remember, we used the test point 0, 0, which is right here. So if that works, we would shade the side 0, 0's on. In other words, if I get a true statement. If it doesn't work, I will shade the other side. Okay? So if I put in 0 here, and for x, 3 times 0 is 0, minus 7 would be -7. So is 0 less than negative or equal to -7? No, that's false. Okay, so that means I don't want to shade the side zeros on, so I want to shade the other side. So that would be this way. Okay, now I'm not going to shade this all the way through here. I'm actually just going to kind of do some arrows saying that I'm shading this way, and you'll see why in a second, because you're going to get a lot of stuff on here and it's going to get a little confusing. So I'm just gonna really say we're shading that way, and then we'll talk more about that in a bit. Okay, so now this other one I'm gonna do in blue. Okay, so it says y is greater than negative 3/4 x plus 8. That means our y-intercept, we want to start there. So plot positive 8 on the y-axis. My slope is negative 3/4. I like to put the negative on the top. You can put it on the top or the bottom, but don't put it on both, right? Top or bottom. So my rise is negative 3. That means down 3 units. And a run of 4. So run of 4. And that means I would plot a point right there. Okay, so I'm going to put a dot right here. Okay, and then draw my line. I'm going to go to the scissors again, make some adjustments. Okay, now this is greater than, so I want a dashed line. So I'm going to do the eraser and just kind of make it look a little bit better. The points on this line are not included. And now I've got that. All right, now next thing I want to do is test point 0. Plug in 0 for x. That'll give me 0 here plus 8. So 8. Is 0 greater than 8? No, that is also false. Okay, so that means, again, I'm not shading the side 0, 0 is on. 0, 0 would be, if that worked, we would shade this way. So it didn't work, so we're shading the other way. That means this way, up this way. So you'll notice the shaded region is above there. What we're looking for is where the blue shaded region and the purple shaded region would overlap. So if you'll notice, that's this section right here, okay? So I wanna shade that and make that really obvious. So let's do that. I'm gonna do the highlighter, and we'll kind of highlight that in there. Okay, so this is the shaded region. Any point in that region is a solution to this system. Okay, so like the point 8, 8 would be in that solution, that pink region. Okay? And that's my answer. If you wanted to get rid of those other little arrows that you had in there, I usually end up doing that, but I just kind of left it there for this time. Okay, so here we go. Let's try another one. Okay, graph the system of inequalities and go and then go from there. Notice both of these are in standard form, so I want to use the cover-up method. So I'm going to start with this first one, and we will let's do this color. Okay, so I'm going to start with my x-intercept. So I'm going to cover up the y. That means I'm covering up this. Pretend like it's an equal sign for now, and you say 3x equals 24. Divide by 3. X, my x-intercept, would be equal to 8 then, right? So on the x-axis, 8. Okay, now we're going to cover up the x and find my y-intercept. Okay, so my y-intercept would be, I have negative 6y equals 24. Again, pretending like it's an equal sign for now. And then divide by negative 6 on both sides, and that would give us a y-intercept of negative 4. So I want to make a dot on the y-axis at negative 4. Okay, this is the fastest way to graph standard form. We've talked about this before. And now I'm going to, whoops, don't want to do that. I want to draw my line. Okay, that's pretty good. Maybe a quick tweak here. Okay, now it says greater than or equal to, so I want to leave it as a solid line. Okay, and then I'm going to use the test point. If I put a 0 and a 0 in for there, and a 0 in for there, that's going to give me 0 on this side, 24 on this side. Is 0 bigger than 24? No. Okay, so I'm shading away. So I'm shading this way. All right. Now let's do the other one here. Okay, so I'm going to start with my x-intercept, cover that up. So I would have, oops, x-intercept would be 3x equals negative 15, so x is negative 5. So on the x-axis, negative 5. All right, now cover this up. Okay, divide there, we get our y-intercept is negative 3. Okay, now I want to draw my line. Again, this is going to be, I guess I can erase this. This is going to be a solid line. Okay, that's pretty good. Leave that. And then which way do I want to shade? Well, if I put a 0 here and a 0 here, that gives me 0 is less than or equal to negative 15. Once again, this is a false statement. So away from 0, 0. If it was true, we would shade at this side 0, 0 is on. So I'm shading this way. Now, where do these red and like aqua colors overlap? They overlap right in this region here. Okay, so I want to make sure that that gets shaded. So this time, I'm going to erase these little arrows. I know I need this spot to be shaded, so I'm going to go back and do that. Okay, and that's the solution region. To me, that looks just a little cleaner and nicer. Okay, and then one more, just with horizontal and vertical lines. And here we go. So this one has just a little different thing. And this first one is just in slope-intercept form. So positive 4. Slope is negative 2, so down 2 over 1. You can do that a couple times if you want. However you want to go about that. Okay, it's a solid line, less than or equal to, and if I put a 0 here, oops, 0 here, and 0 there, is 0 less than or equal to 4? Yes, true. So I want to shade the side 0, 0 is on. So I'm shading this way. Okay, that's our first one. Okay, now this one right here, remember y equals 6. That's a horizontal line at 6. So I'm going to draw horizontal line. It's or equal to, so I can leave it as solid, and I'm shading less than or equal to would be down. You can test point if you want, but it's down. And then lastly, we'll do this. This is a vertical line, okay, at negative 5. Okay. This one, notice it's greater than, so I'm going to make it dashed. Okay. All right. And now, which way do I shade here? So if I, greater than would be everything to the right of this graph. So that would be this way. So now really, where am I looking that these overlap? You have to wear all three, the blue, or the dark blue, the purple, and the green all overlap. And that would be here in this region right here. So I want to highlight that. I'm going to get rid of these so we can kind of do that. Okay, so here we go. I'll stick with pink because it's real bright. Okay, I'd probably clean that up a little bit, but you get the idea. That's the solution region. And hopefully solving systems of inequalities makes sense now. Okay, when you do this on your assignment, make sure your solution region is really obvious. You can write this into your planner, Systems of Inequalities worksheet. Again, write it into your planner, that right there, so you've got it. All right, I hope this makes sense. Have a good one. See ya.